In this video I want to remind you of the process of polynomial division. And so in the first little bit, what I want to do is I want to remind you of integer division. So here's a problem. I have 18,644 divided by 23. And if you remember the process of long division, what we're interested in doing is we're interested in seeing whether the number 23 goes into the digits, and typically we start with 1, too small, 18, still too small, 186. So 186 divided by 23, we could use our calculator and find that the answer is 8. That's the largest integer. That when you multiply by 23, you get something less than or equal to 186. Multiply it out and you get 184. So that was 23 times 8 was 184. So the next step is subtract, and so we subtract 184 from 186 and we're left with 2. So then we bring down the remaining digit and we say, does 23 go into 2? No. Does it go into 24? Yes. One time. 1 times 23 is 23. We subtract. We bring down 1. 23 doesn't go into 1, nor does it go down into 14. And so we are left with a remainder of 14. So when we interpret this, what it tells us is that 18,644 is the same as 23 times 810, but I have a remainder of 14. Now when we look at polynomial division, we're going to go through the same basic process. Instead of looking at just individual numbers, we'll look at monomials, the individual terms of the polynomial. So what we'll do is we'll divide the monomials. We'll then take our answer and multiply it by our divisor, and then we'll subtract from our polynomial to see what the next terms are that we need to worry about. And so we'll repeat that. So our first problem, we look at our first monomial, 2x cubed, and we look at the leading term, 2x, in our divisor, and we divide. And so 2x cubed divided by 2x simplifies to just x squared, and so that'll be the first term of our answer. Now the second step is to multiply. So we need to take 2x times x squared. That gives us 2x cubed. And we'll take x squared times 1. That gives me x squared. And you'll notice I didn't put any signs down. Now the reason for that is the third step is to subtract. And so I want to actually subtract, so I'm going to change the signs. And then I'll add. And so what I'm left with is the 2x cubed and the minus 2x cubed cancel. I now have minus 8x squared minus 14x plus 3. And so now I look at the leading term. Negative 8x squared divided by 2x. So negative 8x squared divided by 2x is negative 4x. Getting a little cramped there, sorry. And that's the second term of my answer, minus 4x. So that's the dividing monomials. Next I'll multiply. Negative 4x times 2x gives me negative 8x squared. Negative 4x times 1 is negative 4x. You notice this time I wrote down the negative sign, but because I really want to subtract, I'm going to change the signs, and then I will add, because subtraction is adding the opposite. I'm left with negative 10x plus 3. Alright, so we're almost done. I look at the leading term, negative 10x. I want to divide that by the leading term, 2x. That gives me my last term. Negative 10x divided by 2x is 5. And so I have plus 5 as my last term. And now we multiply. 5 times 2x. Look at that. I forgot a negative sign. Negative 5. Negative 5. Negative 10x. They have to cancel. That's how I knew I had a mistake. And negative 5. I want to subtract. So I change the signs. I add. And I get negative 10x cancels. 3 plus 5 gives me 8. And that turns out to be my remainder. My remainder is 8. Alright, so let's take a look at what that means. Alright, if we compare the division problem for our polynomials to our integers, then what we learn is if I take our divisor, 2x plus 1, we multiply it by our quotient, the answer, x squared minus 4x minus 5. That's not quite the 2x cubed minus 7x squared minus 14x plus 3. I have to add 8 in order to get my original polynomial. And so that's the interpretation of the remainder. The remainder is the piece you have to add in order to recover, you need to add to the product in order to recover the original polynomial. So notice if the remainder is 0, that means it's a perfect divisor. In other words, you found a factor. Synthetic division is a way of doing polynomial division for special types of divisors. In particular, they're of the type x plus or minus a number, x minus c. So on the left I've already drawn a long division problem that's of this type, and here I want to point out that c is equal to 2. And so all of the division's already been done. Just take a look. X cubed divided by x is x squared. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. I change the signs for subtraction and I add. Negative 5x squared divided by x is negative 5x. Negative 5x times x is negative 5x squared. Negative 5x times negative 2 is positive 10x. I change the signs for subtraction and add. I get 4x. 4x divided by x is 4. That's my last term. 4 times x and 4 times negative 2 give me 4x and negative 8. I change the signs for subtraction, I add, and I'm left with a remainder of 2. Alright, so synthetic division says let's take just the coefficients of our original polynomial. And so for us, the x cubed term had a 1. I forgot. Alright. The x cubed term had a 1. The x squared term had a negative 7. The x term had a 14. And the constant term was negative 6. My value of c is 2. I always start by putting a 0 in. And now I go through a process of adding and multiplying. And so I come down, I take these values 1 and 0, and I add them. Next, I take the 2 times the 1 to multiply. Notice the angular direction reminds me of multiply. And so 2 times 1 is 2. I now go vertical. Negative 7 plus 2 is negative 5. Then do an angle. 2 times negative 5 is negative 10. I then add, and multiply, and I add. And I want to emphasize the relationship between these terms. The 1 corresponds to the coefficient of the 1x squared. Negative 5 is the coefficient of negative 5x. The 4 is the coefficient of the constant, and the 2 is the remainder. And so every time I do synthetic polynomial, I can quickly identify the value of the quotient, x squared minus 5x plus 4, with a remainder of 2. In the language of multiplication, this long division or synthetic division translates to saying that our divisor, x minus 2, times our quotient, x squared minus 5x plus 4, plus our remainder, 2, is equal to that original polynomial, the cubic. Notice that if the remainder had been 0, so this term is gone, I would have a perfect factorization. So let's illustrate this with one more example. I'm going to take this cubic polynomial, x cubed minus 3x squared minus 10x plus 24. I'll divide it by x plus 3. Notice that my c value, x plus 3 equals 0. If I solve that, I get x equals negative 3. And so the value of c I'll use in synthetic division is negative 3. Alright, what are the coefficients? X cubed is 1, x squared is negative 3, x is negative 10, constants 24. If there's ever a term that's missing, you just write down 0. Always start with a 0 here. Now every time we go vertical, we add, then we multiply. Negative 3 times 1. Add. Negative 3 times negative 6 is positive 18. Add. Negative 3 times 8 is negative 24. Add. I get 0. The 0 is my remainder, and these others are my coefficients, and I can write down the answer. It's x squared minus 6x plus 8 with a remainder of 0. And so I've just found a perfect factorization. X plus 3 times x squared minus 6x plus 8 is equal to the original cubic. X cubed minus 3x squared minus 10x plus 24. Notice that this other quadratic is one that I can also do by sight, maybe. X minus 2 times x minus 4. Sometimes that's called reverse FOIL, that process. And so I now have a complete factorization of the cubic polynomial. Synthetic divisions would help me do that.
Made with Doodlecast Pro.